Good morning to everyone. I am Dr. R.S. Ramkumar, Head and Assistant Professor, Department of Mathematics at Sri SRM College, Satu. Today we are going to see about the topics in set theory and metric spaces. First we will see about the metric spaces. Here the definition of a metric space is nothing but let M be any set, a metric defined on M is a function rho with the domain M cross M, that is a Cartesian product of the set M and M, and the image set, which is the range, is contained in the closed 0 to infinity. It satisfies the four axioms. The first one is the distance between the point x and itself is equal to 0 for every x in M, and also the distance between any two points is greater than 0 where x and y are belongs to M, and also x is not equal to y. That means if x and y are different points, the distance must be non-negative. Distance must be strictly positive. The third axiom is the distance between x and y is same as the distance between y and x for every x and y in the given set M. The last one is a triangle inequality. The distance between x and y is always less than or equal to the distance from x and z and plus the distance from z to y. So for every point x, y, z in M, then the distance function rho is a metric for M. So hence the ordered pair M along with the metric rho is called a metric space. So these are all the examples for the metric space. The function rho is defined by rho of x comma y is equal to absolute value of x minus y. The set is nothing but it is a set of real numbers. So in the real number set, we define a metric as the absolute value of the difference between 2 points x and y. So these are all the four axioms. The modulus value, the absolute value, is always non-negative, always greater than 0. It should not be negative. If 2 points x and y are same, that means x is equal to y. We get the metric value is equal to 0. Modulus of x minus x, which is equal to 0. That is the point distance from a point to itself is 0, and the distance between x and y is greater than 0 if these 2 points x and y are unequal. That means x is not equal to y. The distance between two distinct points is strictly positive. And the next axiom is rho of x comma y. The distance from x to y is always equal to the distance from y to x. The last one is a triangle inequality. So in the real number system, modulus of x minus y is less than or equal to modulus of x minus z plus modulus of x minus z minus y. So this satisfies the triangle inequality. So from that we can conclude the distance defined by modulus value, absolute value of x minus y defined on a metric space R satisfies the four axioms. So the set R along with the absolute value metric is called a metric space. Thank you.